In this lesson, students solved unknown or missing side lengths and perimeters. I am going to show you a few examples of how students might solve missing side lengths and the logical reasoning for finding the length of sides when none are given. Our first example is missing only one side length. If this is a four-sided quadrilateral and the perimeter is 28 inches, I can find the missing side length by adding the sides that are given and then subtracting the sum from the perimeter length. I start by adding the 5 and the 6 to get 11. I then add the 7 to get the sum of 18 inches. Now I will take the perimeter length of 28 inches and subtract the 18 inches to find the missing side length of 10 inches. Let's look at this pentagon. If two side lengths are given and the perimeter is 18 centimeters, we need to find the side lengths for A, B, and C. I notice that side A appears to be the same length as the 3 centimeter side. I will label side A as 3 centimeters. I notice that side B appears to be the same length as the 4 centimeter side. I will label side B as 4 centimeters. Now I will total the four sides that are labeled. 3 plus 3 is 6, plus 4 is 10, and the other 4 makes 14 centimeters. Now I will take the perimeter and subtract the total. 14 centimeters taken from 18 centimeters leaves 4 centimeters for the missing C side length. Now we have a shape where all the sides appear to be the same length. The perimeter of the shape is 24 inches. Knowing that a hexagon has 6 sides, I would take the perimeter of 24 inches and divide it by the number of sides, which is 6, to find each side length. I know that 24 divided by 6 is 4, so each side length will be 4 inches. Now let's look at one last shape. I am only given the perimeter of this shape. In the previous problem, the shape appeared to have all the sides the same length. Clearly, this shape does not have all 4 sides the same length. I will need to use some logical reasoning to find all 4 side lengths. This problem is open-ended and allows for multiple correct answers. I notice that the 2 side lengths on the top seem to be the same length. I also notice the 2 side lengths on the bottom of the shape seem to be the same length. I could divide this shape in half vertically to have 2 sets of lengths that appear to be the same size. Therefore, half of the perimeter would be 2 of the side lengths. By dividing the perimeter of 20 centimeters in half, I get 10 centimeters. One combination that would not be possible is to have each side be 5 centimeters. Although the perimeter of the entire shape would be 20 centimeters, all the sides are not the same length. Therefore, I must have different side lengths. Having one of the side lengths be 1 centimeter and the other 9 centimeters does not make sense because they would not be proportional to each other. This side is not 9 times longer than this side. Using the same reasoning, the side lengths of 2 and 8 would also not work. I have reasoned thus far that the top 2 side lengths could each be 4 centimeters, leaving the bottom 2 side lengths to be 6 centimeters each. Or having side lengths of 3 centimeters and 7 centimeters could also work. When students are given an open-ended problem that has more than one correct answer, the reasoning behind the responses becomes very important. In our lesson today, we learned to solve for missing side lengths and perimeters by using logical reasoning.